A ton of real life applications, including probability, statistics, physics, and even machine learning, and an easy to understand concept. We have seen multiple instances where these two go together. One of them is Jensen's inequality. Suppose you have a function which is convex. We will come back to convex functions in a bit. Jensen's inequality states that f of p1 times x1 plus p2 times x2 up to pn times xn is always less than or equal to p1 times f of x1 plus p2 times f of x2 up to pn times f of xn, where the xi's are the real numbers and the pi's are reals and add to give 1. By the language of probability, we say f of the expectation of the random variable x is always less than or equal to the expectation of f of x. Now consider this function. We say that the function is convex if in the area above it we take 2 points and the line joining them has all its points inside the area. In terms of inequality, if we take two inputs and some positive p less than 1, plot them, then take the sum p times x1 plus 1 minus p times x2 and mark the corresponding y coordinates on the function, we will note that it is always less than or equal to p times f of x1 plus 1 minus p times f of x2. Now, when do we get to see equality? It's when it's a straight line. Now for the general case, let's try to visualize the inequality for a convex function. Let's take a few x values. The weighted sum is denoted by the blue line, and the red point denotes the weighted sum of the f of xi's. We can clearly see that the red point lies above the blue point. Thus, we have the following inequality. Now, let's try to understand the proof by induction. By the definition of convexity, we have the base case satisfied. By the induction hypothesis, we assume that the inequality is true for n number of inputs. Now for the case of n plus 1, the pi's get added to give 1. Let's write it like this. Let's now write this sum in the following way. Now I note these two numbers. They add to give 1. So by the definition of convexity, we can write the following. Interestingly, we can write that this particular sum gives 1 and it involves n elements. Therefore, by the hypothesis, we can write the following, which is nothing but this, and we are finally done. It's also important to note that for the case of concave function, which can be defined antagonistically in the exact same fashion, we will have the inequality reversed.